right, I think I'm set up here. If someone on the live chat could just let me know if they can see and hear me okay. Let me know if the audio is at a good volume. I can futz around with that if need be. And let's see. So here I am, waiting to see if I can pick up. All right, so people are seeing and hearing me. Great. Awesome, friends. Well done. Thank you, technology. I have made my offering, and hopefully it is sufficient and adequate. Thanks, of course, to Susan for being our moderator. That's proved to be a huge help to me, and I think most of you would also agree that it is a better situation to have her in there. Thanks to all of you for joining me. We'll kind of chit chat for a bit here, and then we'll get started in about 7 minutes. If you're in Europe, I appreciate you staying up late into the evening. If you're over in New Zealand or Australia, I have no idea what time it is, but thanks again for joining us. I really do appreciate it. Let's see here. A couple shout outs. I'll try to get to the chat here. Tom from Arizona, Rebecca from Oak Island, North Carolina, Tanya from Finland, Jeff from Aurora, Colorado, Ann from Wenatchee, Washington, Elaine from Tucson. Hello, Elaine. Barbara from North Idaho. Our good friend Amanda Joe is on here, from a Grindavik resident, soon to be a resident of a new town. I can't remember it off the top of my head, but I'll look it up. Ace 10 is here from Northern Iceland, I believe. Let's see, going down the list a bit here. Yeah, everyone says I'm 5x5, which means everything looks good. Michael Mikhail from Shropshire, UK. Another Sean out there, S-E-A-N, saying some nice things. Says it's a shame that my name is spelled wrong. Ha! My name is spelled just like it sounds, fella. Anyway, 3 different ways to spell it. Maybe more, who knows. Maguire from Germany. Joanne from Chesapeake, Virginia. Joanne, I sent you a letter in the mail. I did receive your nice handmade gift. My wife wants it. We'll probably end up sharing it. She knitted me a hat. It's awesome. It's soft and superb. So thank you so much for sending that. I did send you a thank you card in the mail just today. Two Stone Brewing from Saskatchewan. Marlies from Germany. Line from Switzerland. Mary from Maryland. That's fun. Melanie from Colorado Springs. If I miss you, I do apologize. So they come fast and furious. And my eyes are getting worse and worse, I've noticed. Jutilia from Finland. Wendy from Melbourne, Australia. 9 a.m. there. Oh, so that's not too bad. You're just getting up, having your coffee, hanging out. Not too bad at all. Bunkinator from Sweden. Michelle from Seymour, Indiana. Christina from Rheinbach, Germany. Jill from Tampa. Some more German folks here. Greg in Eastern Tennessee. How are you doing, my friend? Michelle from New Jersey. Pam from Kansas City. ICU, Michigan. Vivid Magic, first time live. Greetings from Eindhoven. Don't even know where that is, but I will find it on a map soon. Richard from Florida. Hard Rock Girl from Dorset, UK. Anita, the Netherlands. Lisa from Canada. Peter from Boulder, Colorado. Dora from Klagenfurt. Harold from Nova Scotia. This is just great. The wonders of technology, right? It was against me on Sunday, and now as I'm greeting all these wonderful people in far-flung areas of the world, it's amazing. Ray from Ely, Minnesota. Kobe from France. Claire from Toronto. Ed from Winchester, UK. Sharp Lisa from Ontario. Janine from Wakefield, Massachusetts. Deborah, West Virginia. Arwen from Lancashire, UK. Karen from Estonia. That's exciting. Man, wouldn't it just be fun if we could just go visit everyone in their hometown? That'd be a dream. Flying Turtle from Hawaii. Aloha. Susan from Ontario, Canada. Megan from Salt Lake City, shout out SLC. Edwin, Netherlands. Northern Lass from the heart of Texas. Tony from Leicester, is that how you pronounce it? UK. Tony from England. Jills from the Netherlands. Pete from Spain. O.D. Van de Veer from Netherlands. Elizabeth from Fife, Scotland. David from Derbyshire. Boy, so many folks jumping in here. Randy from Minnesota. Helen from England. No, I'm not going to fly the drone today. I've got news about the drone, and it's not awesome, at least in the short term. But long term, it's good news. Lisa from Edmonton. Johan from Sweden. Dawn from North Carolina. Mike from Oceanside. Monet from Augsburg, Germany. Joe from Iceland. Andrea from Virginia. Lee from UK. Sunny from Bremerton, Washington. Roscoe Van Wyck from South Africa. Awesome. Kyle from Moneta, Virginia. The passive margin. Yes, but still reputable. Still known for good geology. Carl from Sweden, where we don't have much, if any, active geology. No, but you can. That's the beauty. You can be a geology fan from anywhere. Melanie from the Nicoya Peninsula of Costa Rica. Hola. Daniel from Great Britain. Yeah, if you hit the like button, that's always helpful. I always forget to mention that. Susan's jumping on there and giving you guys good information about how she wants to have the questions formatted. If you're used to Nick Zentner, we do things a little differently here. So maybe follow Susan, the moderator's instructions on getting your questions through, and we'll get to those at the end. But yeah, hitting the like button does something awesome on the internet. Good things happen. Sharing, subscribing. We build the geologic community one brick at a time. Nick from Oswestry, UK. Mary from North Carolina. Susan from London, Ohio. Johnson 68 from Sweden. Larry from Bend, Oregon. Kelly from Wisconsin. Chroma from Tennessee. I've got 1 minute left to get as many of these in as I can. TT Happy Rock from the Boring Lava Field. That's in Oregon, and it's not boring. Geoman from Sun River, Oregon. AJ from Rock River, Wyoming. Spinderella. Girl Sean from White Mountains, Arizona. Okay, whatever that's about. Mama K from Wallace. Let's see. Arthur from Isle of Skye, Scotland. Brian E., how are you doing, my friend, from Vancouver. Carmen from Belgium. Some handle I can't pronounce from Germany. Germany is strong tonight. Slovakia. Richard from Virginia. Michael from Oregon. And all sorts of other people. Una, Ireland. Giles from Kent, England. Emily from Rexburg. Misty from Mount Angel, Oregon. Leaf from Norway. Martin from Sweden. We've got an international crew here, which is great. I probably missed a few folks there, so I do apologize, but you can read the live chat just as well as I can read it, if not better. So let's go ahead and get started. So, sweet. Thanks so much for joining me, team. My name is Shawn Willsey, geology professor. Thanks for joining me here today. Thanks for being part of our geologic learning community, and I really mean that when I say that. This is not just me. I'm maybe I think I'm the coach, I guess, of the team, just kind of motivating us all, but we're learning together. If you're new to the program, thanks for jumping on here. I don't live stream all the time, but I will try to get one out every once or so. Well, one every 1 to 2 weeks is sort of my goal, unless there's more going on. I want to just, first of all, just express my gratitude for everyone's viewership, your support, your encouragement, a beanie that Joanne knitted me, emails that you send me. My email inbox, which has always been nice and tidy for my entire professional life, is now, I wouldn't say morbidly obese, but it's bulging. And if you've emailed me something and I haven't got back to you, I apologize. I'm trying to get to all of those, but I'm backed up for sure. But I will try to get to your email, especially if I feel like the email warrants. If you're just kind of giving me an FYI, like, hey, I saw this video, here's a paper, then know that I got it, know that I looked at it. But if you're waiting for a response, just know it might take a little bit of time, especially now that I'm back in the classroom and teaching. bandwidth is decreased a little bit, but I still want to give you good folks the attention and my best effort as best I can. So let's go ahead and get started. Here is the outline of what I've got planned for today, and I hope you can stay with this as long as you can. If you need to duck out, no big deal. This will be recorded. It'll be up on my YouTube channel. I'll be sure to go in afterwards and add little chapters so you can maybe skip around and find the exact portion of the live stream that you want to check out or be involved with. So we'll start with this fun event that I had this past Sunday that many of you are aware of on another YouTube channel we were on together. I'm told in the business of YouTube, this is still a new term for me, that this is called a collab, like a collaboration. So that was kind of a new thing, but it went really well, and I think we had a good time, and I think we'll probably do more moving forward. Then I will get to what probably many of you are excited about, and I will provide an update on the situation in both Iceland and Kilauea. I'll probably start with Kilauea first because it's a little bit shorter. And then we'll move on to Iceland. I've got the usual run of looking at the data, and then I've got a couple new things at the end I'll share with you. As always, if you're new to this program, what I try to do as a responsible scientist is present the data, the facts, the things that we know, and try not to slip into, and it's easy sometimes, slip into speculation, hysteria, the kind of clickbaity stuff. So I'm a boots on the ground kind of geologist. What are we seeing? What is the evidence? And then we might talk about possible hypotheses, interpretations, but for the most part, I try to stick to what is known and not spend too much time out there speculating on what might be and what could occur. I got some field trip announcements that I'll share with you towards the end, and at the end of the program, we'll open it up to viewer Q&A. Our good friend Susan, the moderator, will be aggregating those questions, and then she'll email those to me. I'll try my best to get to as many of those as possible. But please know this, if I don't get to your question, Susan does a great job of collecting those, and if I don't get to your question today or this evening, I will make sure in a future video update to include those. I'm assuming a lot of the questions will be on Iceland or Kilauea, but they might be on something else. So I try to at least get to those at some point, even if it's not during this exact live stream. So that's our map of where we're going. Let's get this boring slide off the screen. And get the party started. And oh wait, we're actually going to stick with the slides for just a second. I apologize, but we'll go to our first item here. So this past Sunday, February 4th, I was a guest on Nick Zentner's YouTube channel. If you're not familiar with this individual, he is a fellow geologist. He teaches at Central Washington University. He has been very active for most of his career, and certainly the last 10 years or more in doing things very similar to what I do. He does a lot of geologic outreach. He tries to include the public. He and I have spoken, and we have very similar philosophies on some of the problems with science and the lack of communication of science to the general public. So I think he's made it his life's mission, as I have, in trying to find ways to share exciting geologic discoveries, research, developments, happenings with the general public. And he has a really productive YouTube channel. He's way more prolific than I am. I don't know how he balances all his teaching and everything else, because it's sometimes just a little bit overwhelming. But anyway, he was doing a Ice Age Flood A to Z series. So literally 26 episodes on various portions of the Ice Age floods, and most of those episodes were devoted to the Lake Missoula flood. So these big cataclysmic floods that went across eastern Washington as a glacial lake in Montana was backed up behind an ice dam that periodically failed catastrophically, producing these tremendous torrents of water that raged across eastern Washington and that part of the Pacific Northwest. And I actually injected myself into his episodes. I emailed him, maybe, I don't know what episode he was on at the time, but it was maybe a little bit before Christmas, and said, hey, would you consider looking at a different ice age flood, the Bonneville flood, which is a topic I know a lot about and an area of expertise that I've attained in living here in Twin Falls and reading a lot of the literature and investigating a lot of the outcrops. And he said that would be great. And so we arranged a date, which was February 4th. It was all set up. Last Friday, we got on a Zoom call and checked out all the AV stuff, made sure all the technology was working. Everything looked kosher. I was going to record it on my end, and we were off to the races. So Sunday, February 4th came. I came into the office early, a couple hours early, to get some stuff ready, make sure I was good to go. And then maybe about an hour and 40 minutes before I was supposed to go on with Nick, I noticed that the internet here at the college wasn't working. And, at first I thought, well, it's just a glitch. I'll restart my computer. Maybe that will be helpful. And then slowly but surely I realized that this was a bigger problem. It wasn't just my computer. This was the entire campus. And so the panic set in. And like any, well, at least this is how I operate. When the panic sets in, I call my wife. And so she lowered my temperature a little bit, said, hey, let's go to my office. She works at a local elementary school as a school counselor. So we quickly shifted gears, got into her office. She has a 2-monitor setup just like I do. And I'm like, okay, I can make this work. It's not ideal. It's not my home. I don't have the home court advantage anymore, but this will be okay. And so we got there. We were getting all set up. Everything was looking good. And then like Nick got on and like I'm not getting the email from him to the Zoom link. So I'm not. And then what's happening on her computer is her internet still seems to be working, but is just the little wheel is spinning, right? Like the internet's not doing its thing. It's not sending me to the Zoom link so I can get on with Nick. So this is literally like 10 minutes before the show's going to start. And so I went from plan A at my office to plan B at my wife's office on her computer. Luckily, I had my laptop with me, and ultimately we had to go to plan C, which was just popping up my little laptop with one monitor. It was not ideal. It was very wonky. But Nick was such a great host, and I got into the flow so quickly that I think it went okay. Like in the moment, I thought, this isn't awesome. People are going to be like, thumbs down, meh. But I watched it in replay, and I watched it and thought, well, this is actually not bad. This turned out better than I thought it would. So just wanted to share that a little bit if you weren't aware of what was going on there. So, but I did get to share a little bit on the Bonneville flood, showed some slides. It went great. And the follow-up to this is that because I was on Nick's program, he's agreed to come on my channel probably late February to early March. And we're going to do a live stream with him as our guest. Now, I've never had a guest on my channel before, but I'm a pretty good people person, and I think I'm a little bit more natural and loose and myself when there's someone else there, as opposed to like right now where I'm literally talking at my computer screen with headphones on. And if I turn to my right, I can see all your wonderful names and a live chat going on, and that lets me know that there's someone on the other end of this conversation. But of course, I can't hear you, I can't see you, and so it's somewhat limiting. So the good news is it went well. The second bit of good news is that Nick is going to be on my live stream, and the topic we'll probably explore. We're probably going to go in a couple different directions, but I think he and I'd like to mainly focus on with him how science is portrayed, how he and I outreach to the public, what scientists do wrong, and how science becomes a bit of a bit controversial in the mainstream public. I'd like to explore some of those topics with him. And so that's the idea. And then who knows where it'll go from there. Maybe we'll start doing more stuff together, because I think a lot of people got a kick out of having us together on the same thing. So we'll see where it goes, but that's the idea. So there you go. So I encourage you, if you haven't already, to check out his work. He mainly focuses on his part of the Pacific Northwest, but he dives deep. So where I'm kind of like looking at Iceland and Hawaii and taking you all around the Western U.S. on little field trips and videos, just giving you little highlights and stories, kind of like the storybook version. He's like hard into the research, interviewing some of those people, and does a great job with it. So there you go. Okay, so that's enough about that, but thought that was important and a fun thing to share. And, oh, and Nick's actually on here. Awesome. So I just talked about what we're going to do with him. So great. Thanks for being on here, Nick. Yeah, we'll do something fun together for sure. I think we had a good rapport there. So let's go ahead and turn to the last update I did last Friday, which was the 2nd. I did kind of a double whammy. There was 2 volcanic regions that I have a connection to that I monitor a little bit on my own that were showing potential signs of eruptions, and so I packaged it all together and did, well, I guess it was 2 separate videos now that I think about it, but in one day I did a video on Kilauea, did a video on Iceland, and so what I'd like to do today is provide an update on both of those locations here. So let's go ahead and switch over to looking at Kilauea. So we'll start with Kilauea first, and then we'll move over to Iceland. So I want to look at the USGS update for Kilauea, and right away you can kind of, without me saying anything else, you can see exactly where this has gone over last Friday. Remember, Friday our volcano advisory level was orange, and orange means that there are signs of activity. All the data seems to be pointing towards a possible eruption. It's what they call watch level. So we're watching the data closely. I'm sure those scientists, are maybe not up at all hours, but they're watching the data coming in closely because an eruption is very likely. And now we've dropped back down, and this is as of even, I've got this here, as of even Saturday, they dropped the volcano alert status down to yellow, which is just advisory level. So I want to go over the USGS update, not read it all to you per se, but maybe hit a couple highlights, and then I'll show you some of the earthquake data that happened over the last week, and then we'll move on to Iceland. And so it didn't erupt. I think back on Friday we were seeing signs that an eruption was very possible. The magma had moved into the southwest flank of Kilauea. It was generating a swarm of earthquakes as that magma was breaking the rock in front of it. And that magma was moving towards the surface in a narrow zone, a tabular body known as a dike. And usually a dike, as soon as a dike is formed and supplied from a deeper magma source, usually, not always, but usually that culminates in an eruption at the surface. And so it looked very much like we were going to have that back on Friday. So what they show here is that at Kilauea that the earthquakes and the ground deformation have subsided significantly. The number of earthquakes we're getting per hour has dropped off. There's still some earthquakes happening, but the magnitudes and the number of earthquakes has dropped off considerably. And then this is maybe if I read one little paragraph, it'll be this one here. Patterns of earthquakes and ground deformation, this kind of summarizes the whole event more or less, indicate that magma intruded beneath the south end of the caldera beginning on the morning of January 27th. So that was back on the Saturday prior, so the week, about 10 days ago. This activity waxed and waned until Wednesday the 31st, when greatly increased seismicity and tilt indicated a dike was being emplaced, triggering episodic felt earthquakes and rockfalls within Halemaumau, that's the summit caldera of Kilauea. By 5 p.m. local time on the 31st, the seismicity migrated southwest of the caldera. So that was kind of the surprises when the earthquakes, which were concentrated near the top of the volcano, started moving down the flank of the volcano on the southwest side. Southwest of the caldera towards the Kauai fault system and tilt meters, which measure the ground tilt or the deformation of the surface. Tilt meters in the South Caldera area began to record strong deflation. So the idea there was that the magma that was underneath the summit area was moving into the southwest flank of the volcano, and so up at the summit, because you're moving the magma away from that area, you get deflation. The land actually sinks down a little bit because you're taking away that heat source and that magma that's below the ground. Modeling data suggests that magma within the initial dike migrated southwest into the new intrusion as it opened beneath the Kauai fault zone. The overall decrease in seismicity and deformation suggests that this event is waning. And I'll show you this with the earthquakes here. However, renewed episodes of activity remain a possibility, and an eruption could occur with little advance warning. So right now the warning signs are showing that the intrusion of magma did not culminate in an eruption. It was just magma injecting itself into a new part of the volcano. That magma may stay there and cool and solidify over long periods of time. It may also be resupplied with more magma and result in an eruption. There's a lot of different possibilities there. So let me show you with some fun little graphics here. This is what we saw, if you weren't with me last time, this is what we saw last week. So this is earthquakes going from the 30th of January to February 2nd. So that would be last Tuesday to Friday. And so if we watch this little animation here, let's start here. So there's the earthquakes coming in on the 29th and the 30th. But watch them really start to pick up here in a second. So we're not seeing a ton of earthquakes. And let me go ahead and pause real quick just to orient you. This is the Kilauea caldera right here. And this is part of the southwest rift zone. So these are occurring more or less in or just slightly subparallel to the southwest rift zone. So let's let it keep going. So here we are, January 30th. And here's over here on the right, actually let me squeeze my little silly face down. There we go. Just above my head here you can see this histogram, this bar graph that shows you earthquake frequency over time. So right now where we are on the 30th, there's a few earthquakes happening, but then you can see these ones really ramp up. So we'll go ahead and let the animation run. So here's the earthquakes coming. And then here they're going to start coming really with a lot of force and frequency on the 31st. Lots of earthquakes. And now watch them, they start moving more progressively down the rift. There's still a lot near the summit, but we're filling in a lot of these spaces as we move to the southwest down the rift zone. And this was indicative or interpreted as magma being injected further and further down the southwest rift zone in that direction. And whoops, hopefully, did I disconnect there? Okay, hopefully we're all still on board. Can everyone let me that it's working okay? Because I just got a little notice from OBS Studio. Someone let me know. Susan, can you let me know if everything's still looking okay? Okay, 5 by 5, and I'm back. And we're back, friends. There you go. Thanks for the commercial break. Anyway, so that was just the earthquake data over that 3 or 4 day window last week going into Friday. Yeah. So let me show you now what it looks like over the last couple days. So now we'll go from the 3rd of February. So literally, got to keep looking at my calendar here. Saturday up to today. So what does the last 4 or 5 days of earthquake data look like around here? And let me set that a little bit slower and run it back just a little bit. Here we go. So here's earthquakes over the past few days. So we're now on February 2nd. This is Saturday. You can see the earthquakes coming in. We could probably speed it up a little bit. And I think you're seeing far fewer earthquakes, right? We're not seeing the earthquake swarms. We're not seeing the concentrations that we saw earlier. And this is 244 earthquakes over a 4-day period, almost 5-day period, as opposed to, well, we'll let those last ones come in so you can see the full picture. But you can see a big difference here, right, in terms of earthquake frequency. So 244 quakes there versus 832 over an actually shorter period, right? Only a couple days on that in that case. So that's the situation at Kilauea. It's a pretty quick update on that front. We will see some other event moving forward. This is the way Kilauea works, is we get periods of inflation, periods of deflation, eruptions, periods without eruptions. This is a map showing earthquakes over the past week. So most of those are those earlier ones, and I'll show you that here in a graph in a second. This is a cross section through this map showing where the earthquakes are occurring. So they're mainly concentrated on the map on the west side over here at Kilauea. That's pretty obvious. And then the circle size is the size of the earthquake in terms of magnitude, and then the color of the dot is the depth of the earthquake, these blue ones being much deeper, and then these orange and red ones being much shallower. Here's our total number of earthquakes as like a bar graph over the past week. So there we are on February 1st. We had up to 700 earthquakes in a day, or darn close. And then you can see it really just drop off. And today we're looking at less than 100 so far today. And even the last couple days were less than 200. And then looking at a similar plot of the earthquakes over time. So you can see really lots of concentrated circles, lots of these earthquakes in the swarm taking place here over the weekend, I suppose. And then as we got into earlier this week, those just really start to thin out. So that's pretty much it for Kilauea. So for now, for Kilauea, we're just kind of waiting to see what happens next. Oh, I do have this I can share too. This is just Google Earth showing the same sort of thing. So here's the caldera up near the summit, the East Rift Zone, which is a known place for vents to open up. We've seen a lot of vents open up there, including most notably in 2018. The Southwest Rift Zone, which hasn't had an eruption since 1974. And then in the update, I read some things about the Kauai fault system. This is a fault system that sort of connects these two together, but is also related to the southward movement of the entire flank of the volcano. I spent some time in the last update talking about how these Hawaiian island chains are sitting on a pile of rubble. They have unstable bases down below the ocean level, and so they do tend to periodically collapse. Sometimes they collapse slowly, sometimes they collapse catastrophically, at least we think, because we can see debris from these volcanoes that goes way out into the ocean. Like, for example, you can see this is Oahu here, and look at how the seafloor out to the northeast here is just this rubbly material. And they've actually gone down, I believe, in submersibles, sampled some of that material, and it matches up with the rocks found on the island. So the idea here is there was a massive collapse of the northeast side of Oahu that produced this huge submarine landslide, probably generated a massive tsunami as well, because you can see some of that debris that goes literally maybe hundreds of kilometers offshore there. So anyway, let me just show you this last thing on Kilauea, and then we'll turn to Iceland. So this is, amazingly, this is me having fun with a new little toy I learned how to download here and put on here. So you can actually use Google Earth and some of the earthquake data from the USGS to show earthquakes occurring over time. So here we are on the 31st, and all the quakes happening. Now we're on February 1st, and then the quakes will go away after a second. And here we are on February 2nd with the earthquakes, and now we're getting into the 3rd. So now we're into this week, and notice how few earthquakes are happening there. Now we're into 2 days ago on Monday. This is yesterday, Tuesday, and then we'll finally arrive at what's happened so far today. So you can just see a gradual just decrease, a rapid decrease of those quakes over time. Do you want to see it again? Of course you do. I do. There we go. Magma's intruding, the dike is formed, and the magma's no longer propagating, pushing through the rocks. It's stalling, probably because the magma supply is waning somewhat, and so it's stagnating, and we're probably just seeing these earthquakes happening as that maybe cools a little bit, and just some of the little regional stresses there. So, okay, good stuff. Let's turn to Iceland now and talk about Iceland. There's much more to talk about on that front than at Kilauea, but I'll try to keep you updated if anything happens over here in Hawaii. I'm very much invested in this area, having traveled there, taken student groups there, looking to take a group of viewers or anyone who wants to go there in 2025 to explore some of the island's geology. So let's switch over to, where do I want to go? Let's switch over to the slides here. And let's start with the earthquakes in Iceland. So the news right now in Iceland, if I had to give you like a 1 to 2 sentence summary, is there is no eruption that's taken place yet. However, the magma system beneath the power plant area seems to be about as primed as it can be. We were seeing a similar volume of magma based on the estimates from the modeling to what we saw prior to the last 2 eruptions. So basically, magma has intruded into the subsurface below the power plant area, just north of Grindavik, and appears to be the same amount of magma that we saw prior to to that eruption. So here's our earthquakes over the last 24 hours. And you can see nothing, huge here. These are all very tiny earthquakes. There's like a 0.3. The depths of the earthquakes varies a little bit. And these are actually color-coded on here. The shallow ones are red. The more kind of, not little deeper ones are yellow, down to about 5 or so kilometers. And then I think they use blue for the deeper ones. So that one over there is about 12 kilometers in depth. And so you can see there's not a real, I'm not seeing anything just in the earthquake data there to suggest an eruption's about to take place. However, remember, we've had 3 magma intrusions here in the last 3 months. We had the November 10th event where magma pushed eastward from the magma sill, the supply chamber of magma, and formed a dike running northeast-southwest and right under the town of Grindavik. That was November 10th. That event did not end in an eruption, but we think that magma got very close, maybe as close as half a kilometer of the surface before it just stalled and started to solidify. Then on December 18th, we had an eruption that took place up in this area, off to the north, near this Stora Stogafelt hill, Seelingerfelt. We have a lava field right now today that is from the December 18th, 2023 eruption. That one pumped out a tremendous amount of lava initially, but it waned quite quickly and it didn't sustain that supply. Then on January 14th, my anniversary, we had another eruption that was further south near this hill here, Hagafelt. And we also had a secondary fissure open up really close to the houses. Some of you were with me when I was flying the drone and caught that live. That was a really cool moment, highlight. And since that time, the system has been inflating. We've been seeing more magma intrude into the system. The GPS data is showing that the land is being uplifted. But we might not see a lot with the earthquakes, because if the next eruption takes place in one of those 2 areas or something similar, we've already created those conduits for the magma to pass through. It's already hot rock at depth. And the only way we really generate big earthquake swarms prior to an eruption, like we saw with Kilauea, like I just told you about there, is when magma is pushing into a new section of ground. It's breaking the rock in front of it. It's widening the fractures. That's what's generating the earthquakes. Earthquakes are fundamentally where rocks break. And so if we look at the earthquake data here, just not a whole lot going on. This shows over the past week or so, this shows a little bit longer, so not just the 24 hours, but the last week in the Reykjanes Peninsula. So there's been an offshore swarm of earthquakes here. Is that magma intruding? Maybe, but we're not worried about offshore eruptions. These are under, I think, hundreds of meters of water. They're not going to be explosive. They're not going to really have any effect on people. But it is worth noting that we think there might be some links between these, seemingly disparate volcanic systems. And so if we do have confirmation that there's an eruption here, there might be some research there or some ways to kind of see how that might affect, if this thing starts propagating to the northeast, could it come onto land here at the tip of the peninsula? Those would all be things to look for. But this is more or less earthquakes over the past week or so, just another data stream there. The Met Office had an update on the 5th, which was Monday. And so let me run you through this. It's a short update here, but continued magma accumulation beneath Svartsengi, so the power plant. Probability of magma flows and eruptions continues to increase. Magma accumulation continues, although, and again, this is Google Translate, so we're getting the whole Icelandic English translation there. Although, I'm just going to translate it into what it would mean geologically. Although the magma accumulation the uplift has slowed down there in the last few days, a similar process occurred for the last 2 eruptions, so we're seeing everything sort of stall, and I'll show you that with the GPS data. According to new models and satellite data, the amount of magma under the power plant is now estimated at about 9 million cubic meters. It's estimated that it takes around 9 to 13 cubic meters, or it's estimated that around 9 to 13 million cubic meters flowed from the sill, the magma body underneath Svartsengi, and erupted near Hagafeld on January 14th. So we're at the lower limit of the amount of magma that accumulated in the last eruption. And that's why I think everyone I'm seeing there scientifically is saying, okay, any time now, right? Like we expect an eruption to happen in the next few hours to days, and definitely within the next few weeks based on everything we're seeing. Therefore, the estimated amount of magma has now reached the lower limit of the amount believed to have accumulated there before the last eruption. There's an increased probability of magma flow and eruption in the coming days or weeks. Since Friday, close to 200 earthquakes have been recorded. Most of them are small at a depth of 3 to 4 kilometers. And there you go. And then they have a map. So this is the latest map using satellite data, kind of like INSAR radar, to figure out uplift. So this is just another way of measuring ground deformation in addition to our GPS measurements. The trick with this one, though, is because it's been snowy there, it's the middle of winter, remember that it's bouncing radar off the ground, and it has to do another pass over it to see how much the ground moved up between the two passes. And if you have the ground on one day, but then the next day you pass over it, it's got 6 inches of snow, or whatever, however many centimeters that is, then it's going to mess it up. And so that's why they're not using the INSAR as much right now, because it's wintertime and the snowfall is not going to be helpful in measuring these very small millimeter scale measurements across there. As such, they did the best they could here. Notice there's some gray patches in the data. So now we're kind of zoomed in. There's Grindavik right there. Here's the December 18th eruption site. Here's the January 14th eruption site, and then there's a little tiny one right there, the vent that opened up by the houses that we caught. So you can see the fissures there in red, the lava fields in gray, the older lava fields from over at Fagardalsfjall from 2021 to 2023 are over here. But then with the colors here, we can see the center of uplift. So the brighter the red, the more uplift has occurred. And so we would interpret that to more or less reflect the size or the aerial extent of the magma body. But notice it's a little bit incomplete. There's these gray patches in here because the amount of snow on the ground disrupted the data that they were able to obtain. But nonetheless, it's somewhat helpful, and it just confirms what we already know, and that is that there's magma accumulating, the land is rising. Interestingly, though, this pattern here is a little bit further west than where I think most people would have put it. We've been tracking the Svartsengi GPS station, which would be located right about here. There's the Blue Lagoon, so the power plant is more or less here. And this is the hill just to the south, Thorbjorn. And so this very red area here is a little bit further west than where, maybe by a kilometer or so, than where we would expect it to be just based on the GPS measurements alone. So that'll be kind of interesting to see, as if, what does that mean? Does that mean that there actually is more magma off to the west than we think, and therefore some of that magma could erupt through some vent to the west? Right now I'd say no, because we already have established a clear plumbing system to these vents over in this area. We've already set up, the magma has a path to get over here, but it really depends on how that magma is cooling, solidifying. Is it solidifying into rock? Well, if it's rock, you can break rock again with more magma, generate earthquakes, and then we might see that signal. If it's still quite molten, then the magma can move through it pretty passively. We might not detect that as earthquakes, but because it's magma moving through slightly more sluggish magma, it's got a clear pathway. And if it's something in between where it's more like a crystalline mush, it might actually be more thick and viscous and not behave as brittly. They might actually inhibit the magma movement more so than the other two members of that spectrum, in which case it might pop out in some new area. So everyone, I think, is in agreement that an eruption is very likely very soon. I think the big question, of course, is exactly when, like what date. You can go to your water cooler at your local office or at the local watering hole in your town, and everyone can throw some money on the table and make bets on when this thing's going to erupt, but we don't know for sure. And until we see some precursor activity, which could be earthquakes or not, It's anyone's guess as to exactly when it's going to occur. And then the second variable is exactly where. Where we saw it erupt in December, where it was in January, where will this very likely February 2024 eruption, where will those vents open up? We don't think it'll happen in town right now, even though there's a lot of cracks in town, just because we just haven't seen any indications that the magma has pushed its way all the way into that area. And so, but really it's just a wait and see game so far. Let's look at some of the GPS data. We've been tracking, this is the Svartsengi GPS station. So the November 10th event, uplift after that, December 18th, uplift after that eruption. The January 14th one was interesting because at least at this station, it didn't have a downward movement at the station, so there wasn't a deflationary trend, which is what we typically see. And then you can see it kind of rising, but look at the last week or so here. Let's maybe zoom in on that and just stare at a bunch of red dots closely. So you can see it kind of rising, little peaks and valleys here. But I mean, the last week or so, it's maybe still trending upwards slightly, but it does look like it's stalling a bit here based on what we're seeing. So that's the Svartsengi GPS station. If we look off to the west, closer to where that red blob was on the satellite ground deformation data, we can see at the Eldvorp station, you can see it really does look like it's flattening out there. So let me take you down to that one. So there it is rising through January and into February, but looks like the last 3 or 4 days or so, realize there's error bars on these, so it could be trending up or down, or it could be plateauing, but overall taking the mean data points there in aggregate, it looks like it's somewhat stalling. So the idea would be the balloon has inflated, the magma has pushed into it, and the crust is no longer able, the interpretation is that the crust is no longer able to accommodate any more elastic deformation and continue to rise and push the ground up. And therefore, if the magma is still coming in at the same rate, which we assume it is, even though it might not be, then that would pretty much set the table for an eruptive episode at some point in time in the very near future. And then one last one here. This is the little hill just to the north of Grindavik, and you can see a similar trend there with the data where it's rising, but it looks like it's kind of stalling a little bit there and kind of flattening out. So we'll see where that goes moving forward. So I want to get to a news story here that is, I think, really interesting. So, and then I've got some subsurface data I want to show you. So this little news story popped up. Boreholes warned of the eruptions. Realize, of course, this has been translated into English. Boreholes in Svartsengi at the power plant. So the power plant, remember, is a geothermal power plant. They have holes drilled down into the ground where they're pumping out the hot groundwater and then using that to generate electricity. And they're also piping that hot water into across the peninsula for people's homes and businesses. So what they're saying here, if I won't read this all to you, but basically workers at the power plant noticed during the last couple events, right? November 10th, December 18th, January 14th, that some of their boreholes, which have sensors on the end of them, so there's probes at the end of the boreholes, and some of these boreholes go down 830 meters. So that's, if you don't speak, let me make this a little bigger. Maybe that's helpful there. There you go. 830 meters. So if you don't speak metric, for my English-speaking friends in America, this would be about half a mile, something like, like 2,700 feet. So it's about half a mile down. They're measuring the temperatures and pressures, and they're seeing some of these temperatures and pressures prior to the eruptions within a few hours or so, or maybe even tens of minutes, are seeing some of these probes and sensors read higher temperature and pressure readings. And so they've seen it enough, and granted it's just been a few events so far, but because it's a possible precursor indicator, they've actually linked it to an automated system. So as soon as the gauge shows a sufficient amount of temperature and or pressure, They get an automated email. They can kind of look at things more closely, and they're even sending that into the Met office there. There's a great video here, but for me, unfortunately, it's in Icelandic, and so I was then able to understand exactly what they're saying there. So pretty interesting. And could this be useful? Well, I think it depends, right? So it would depend on exactly where these boreholes are and exactly where the magma is moving. But let me be clear here. Just because these are sensing an elevation in temperature and pressure in the groundwater system, that doesn't necessarily mean that the magma's, feet or meters away. It's probably a little bit further than that. And so you would really need like a fortuitous instance where you've got these sensors really close to wherever the magma is moving. And so I got interested in this, and I found I guess it's a master's thesis. Yeah. So numerical modeling of subsidence in geothermal reservoirs, case study of the Svartsengi geothermal system. So this person here, Melissa Ann de Freitas, through United Nations University, did some modeling of geothermal reservoirs. So most of what she's done in this thesis is not super relevant, but the part I found really interesting, and I can provide a link to this that I hope you guys can access as well, or I've downloaded it, so if you email me I can try and send it to you. Let's get it blown up a little bit. What I found most interesting is when we start to try to figure out what's happening underneath this part of Iceland, it's difficult because it's subsurface data. We can't see the rocks. All we can see is the surface. We can detect the earthquakes, and that makes it so tricky, right? But before I started teaching, I spent 2 years, and I still do this a little bit with consulting work. I was in the groundwater business. I was a hydrogeologist, and we would take subsurface well logs. So whenever you drill a well into the ground, as the driller is drilling through the rock, they get cuttings, depending on the drilling technique involved, they get cuttings of the rock, which get brought up the tube to the surface. The driller knows exactly how deep they are, and they know where those cuttings are coming from. And on all wells, at least in the US, I'm sure this is true in other countries as well, you have to log or record whatever rock type or soil or material that you're drilling through during those intervals. And so I've been involved in several well drilling projects where I was the driller on site, and as the drillers are drilling through the material and the cuttings are coming up through the return tube, we would take samples of those cuttings. They would put them in cute little trays, and then I, as the geologist, would come along and look at those chipped up rock samples to see what they're drilling through. And I would try to identify the type of material that they're drilling in. And so from that information, we get a nice log, like, for example, from 50 feet to, or meters, whatever, feet or meters, doesn't matter, from 50 feet to 120 feet, let's say you're in, basalt, one rock type. And then from 120 feet to 160 feet, you're in, I don't know, sandstone. And then from 160 feet to 200 feet, you're in rhyolite, some other rock type. And so you get a log. And so the subsurface data turns out to be the only thing we have that can give us some information. It's really not the only thing, but it's direct data, right? It's not geophysical data, which is earthquake waves or gravity measurements. It's actually telling us something about the rock types that are down there. And so this is great because what they did when they drilled these boreholes for the geothermal power plant, they have well logs, of course, and so they have a nice little write-up in here on the subsurface geology. And so I haven't digested this whole paper. I just, in the few hours before we got on this live stream, I was able to look at a few things. And basically what they say here, there's 25 wells drilled in the main Svartsengi field, one over at Elvarp, so the crater row off to the west. And some of them go down to around 2,000 meters below sea level. But here's the part I found really interesting. So because we have this hot water system, I've been sort of envisioning, that all the layers are just what I see at the surface. So we've got basaltic lava flows. There's these subglacial eruptions that produce this rock called hyaloclastite. And even with just the lava flows themselves, you can have really thick, dense flows. You can have more rubbly flows. There's a lot of variability there. But it turns out, and this was just something I hadn't thought of, so this was just really interesting to me, that when the hot water, which also has a special chemistry to it as well, moves through the rocks, it alters the rocks a little bit as well. So here they say that these hyaloclastite layers, so these are layers of broken up rock fragments. It's a subglacial eruption material. I've done a video on these on Tuyas that you might want to look at. But it says here the hyaloclastites are among the most porous and permeable rocks. So the water can move through these very easily. And that's important as we start thinking about this volcanic eruption that might take place, because as the magma is intruding the existing rocks in the subsurface, the properties of those rocks are somewhat important. The magmas might be pushing in one direction, but if there's a set of fractures with open spaces that cut across the way the magma is propagating in a different direction, then the magma is going to follow that path of least resistance and move in that direction. And so we want to think a lot about how permeable the rocks are, how porous they are. And what I found interesting here is that these hyaloclastites, which are porous and permeable, alter quite easily into palagonite. Now, these are some fancy words here, but palagonite's an alteration product. Again, I've addressed it on some of my videos. It's kind of yellowish brown. Kind of looks like this weird staining on the outside of the rocks. But then these turn into clays. And clays, of course, are typically low permeability. So you've gone from a rock that had a lot of porosity and permeability, but as it reacts with the groundwater and it gets altered, it turns into clays. And maybe I need to look up this Franzen 2017 paper and dive into that a little bit. That sounds like a good idea. And then it says here, this alteration significantly reduces the permeability. Hyaloclastite is therefore an appropriate caprock to the system since it prevents inflow of the colder, higher pressured groundwater into the reservoir. So her study is mainly focused on the geothermal reservoir, the hot groundwater, and how they can tap that for energy. And that hyaloclastite, because it alters into clay, doesn't allow the cold groundwater, the melted snow and rain that's seeping down from above, to interact for the most part with the higher pressured, the hot water that they're tapping down below. So I found that pretty interesting. And then they have a cross section here, and this is as I can make it bigger, but unfortunately this copy of this article is a little fuzzy, so I apologize if it's not super clear. The resolution's not awesome. And so what we have here is a cross section from east to west, and then all the numbers across the top there are the different boreholes. So by taking several boreholes and then taking those well logs, you can build a cross section, a subsurface cross section. Now, is this 100% fact? No. The only thing we know for sure is exactly where these vertical lines are, where these subsurface borehole, where the data is coming from. That's fact. We actually have rocks from those intervals at depth, and we know what the rock types are. The spaces in between the lines, that's interpretation. That's us saying, hey, it looks like we've got this layer over here. It looks like it matches this one. They're about at the same level, and then matching those across there. And so what you can see here is they've got some different rocks here, but the blue, I don't know why it's a different shade, but the blue is intrusive rock. So this would be the blue vertical ones are dikes. So they've mapped out some of the dikes in the subsurface. These would be other failed intrusions, because now some of these might be actually feeder vents. So if some of these blue dikes come up and intersect with, I guess, what they're showing as gray lava succession, those could very well be the feeder dike that fed the lava flow. But some of these dikes you can see just are dead ends, right? They may have not been dikes that propagated to the surface at that time, much like our November 10th dike where it formed. So, and they show a fault over here. So sometimes if you can't match up your well logs, and it seems like they're offset a little bit, then that suggests that there's a fault in between there. So they've got a fault here, they've got a couple down here at the bottom, and then one over here. So, but what's interesting is, much like I've talked about before, you can't think about the subsurface area as just magma down here and homogeneous, uniform similar rock above, that there's differences in the rock, there's differences not necessarily in the rock type, because it all is fundamentally basalt or basaltic, but the permeability, the porosity, the density, the degree of fracturing, all those variables are important when we start thinking about how magma might move through this system. So I found that pretty interesting. So anyway, probably enough on that, but yeah, nice little cross section there based on that subsurface data. So I just wanted to spend some time looking and discussing that for what it's worth. So hopefully that made sense. If not, I'm sure there'll be some questions on that possibly later. So I'll make sure I leave that open. A couple last pieces of news, and then we'll get to the field trip announcements, and then we'll get to your viewer questions. So thanks again for joining me and hanging in there. We started about an hour ago, so we're doing okay on time. Okay, some more like human element type news here. So one of the facilities in Grindavik, they were calling it in this article the soccer house. There's a big indoor sports facility that's used both for their soccer teams, but apparently, and I didn't know this until Amanda Jo told me, but they also have an American football club that plays there as well, and her husband's involved with that. So that's cool. I didn't know American football was even practiced or played in Iceland, so that was interesting to me. But unfortunately, with all the fractures that have opened up in Grindavik, and maybe just let's take you real quick over there, and then I'll take you back to the story. So we'll zip across North America and set ourselves down here in Iceland. Let's take out the what's in here that I don't want it to be. Let's take out some of those things. There we go. But if we come in here close to town, here's the main little intersection in town. And so the place that is the indoor soccer and American football facility is this one right here. It's right by the swimming pool. And I think this is like a rec center, like a sports complex. And remember, if we superimpose those grabens right here, so remember these blue lines here are those cracks, those grabens, those subsided or sunken downs area bounded by faults. The light blue one here is the western one that formed on November 10th, and this is the most recent one here, this deeper shade of blue. And because this one goes right through this facility here, they finally have found that underneath the turf that there's these big cracks. There's these big gaping cracks that go down into the ground, and so they're trying to figure out how deep are these, what would it look like to try to fix this. So unfortunately, just more damage, destruction, and ultimately headaches in Grindavik. So not a good thing, but again, also I guess not totally unexpected based on what's happened there. So I thought that was just interesting, something folks might be interested in that they hadn't seen before. And then this is important to Amanda Jo and so many of the residents in Grindavik. So sometime this week, later this week, whatever that is, this is a story from yesterday, they are expected to, I don't know if they're voting on the bill or if they're just establishing or putting forth the bill that will help provide these displaced Grindavik residents with the finances they need, the settlement, right? The housing buyout, if you will, that will give them the funds from their homes in Grindavik that will allow them to move forward. So I know with Amanda Jo, she's really hoping that this gets moved forward, and that will allow them to have the finances to purchase their new home. And she's on the live chat, so I suppose you could ask her questions there if you want to. Okay, so I think, let me check my notes real quick here. I think I did it, team. I think I got through the Nick update, a little debrief, the Kilauea brief update, all the stuff I wanted to discuss on Iceland, including the cool little borehole study there, and some of the other news and notes there. So last couple things, and then we'll get to your question and answers. So let me switch this over. So the last thing is just a little more of an announcement type thing. I've started to do geology field trips with viewers. These began this past October. I did my very first field trip where people from our little YouTube community came to southern Idaho. It was a little with a tiny bit of trepidation that I did that, because you just never know. You're kind of inviting, in this case, 20 plus random people to just show up and hang out with you on a Friday, Saturday, going to look at rocks and such. But it turned out great. The people were incredible, and I should have known that. I should have known just from the community we've built with these live streams and these videos and the comments you guys leave, that we had awesome people. So to that end, I have the same field trip that I offered in October. I'm going to run it back. Those good folks were my guinea pigs. It was successful, and so we're going to have 2 days of field trips in April, the 12th and the 13th. The 12th will be mainly around Twin Falls and the Snake River Canyon. Themes there would be Bonneville Flood, the Yellowstone hotspot, and some of the volcanic rocks in the canyon. So mainly Bonneville Flood erosion and volcanic rocks would probably be the two big themes there. And then on the 13th, we'll go to the west of Twin Falls out towards Hagerman and look at some evidence for other floods, perhaps at Box Canyon, look at the aquifer and the Thousand Springs area, look at the lava dam over near Bliss, and kind of wrap up there. The way these sort of daily field trips work is we'll just meet at a designated place. We'll all quickly organize some sort of caravan. People can ride together, carpool. We'll go to the sites. I'll kind of lead the field trip. We'll discuss and learn together. We'll stop at a park somewhere for our sack lunch, move along, and then we'll wrap up, 4:30, 5 o'clock in the afternoon, and then people can go back to their hotels or go back to their campgrounds or their Airbnb or whatnot. But that's kind of the idea. So if you're interested in that, you can email me. I do have a trip in May to Iceland, but that one's already filled, but I'll do another one in 2025. So if you're interested in that, I can kind of put you on the interested list, even though I'm not taking bookings per se right now. In June, we'll do some other field trips here in southern Idaho, or more, I guess, into central Idaho. I don't have the dates right now because I'm a river rafter, and we just put in for some river permits, and we should know by next week. So by this time next week, actually, the 14th, Valentine's Day, is when we should get notified if any of myself, my wife, or any of our close friends that we go rafting with, if anyone landed a river permit, then whether we get one or not, I will be able to set those dates. So look for an announcement on those dates very soon. Definitely do a day at Craters of the Moon, and then probably work our way up into the Lost River Valley, kind of deciding exactly if that's going to be a kind of a 2-day or a 3-day trip window, and exactly where I'm going to go there. But I'm open to suggestions and ideas. I have ideas, but I'm kind of waffling between we could do this, we could do that. So, and then we'll probably do some other ones later, maybe later in the summer, maybe in July, maybe in August, something in the fall. I'll definitely do at least one more somewhat regional trip later in the year. Just haven't planned out that far. So, and then looking into next year, there's a Grand Canyon River trip, but that's filled already. I'm sure I'll do more of these kind of Idaho, maybe northern Utah, maybe some other places too. Regional trips. We'll do a Big Island trip and then an Iceland one. So if this is something you're interested in and it might be in your wheelhouse, you can email me. I can at least put you on the notification list. Otherwise, just keep watching the channel, and I'll be sure to announce these field trips as they get closer. So. All right, so with all that being said, I'm going to my email over here, and our great moderator, Susan, has sent me some questions. So let's jump right to the questions. And hopefully there's context here. The only downside I've realized with doing the questions this way is you good folks are asking me questions at a given moment in the live stream. I'm still blabbing on for a long time, and then sometimes when I get your question, I'm not sure exactly what the context is, but I'll try my best. So, okay, so from PHLEM, Phlegm Hacker. Oh, okay, good one. What are the chances this whole timeline results in a Plymouth Montserrat type situation? So, I'm assuming from Central City, Colorado. Well, Well, Montserrat was a volcano in the Caribbean. It's a stratovolcano, a very explosive type of volcano that has a very different type of magma than either what we're seeing in Iceland or in Hawaii. And it erupted. I think if this is the right one I'm thinking of, was it the? Oh, I'm thinking of. Shoot, now I've got it mixed up a little bit. The 1902 eruption that wiped out. Was it Saint Pierre? I don't know. Maybe if someone in the live chat remembers that story. Anyway, that's a very different type of eruption, so I don't think we would see that in either. I'm assuming you're referring to Iceland, but even if you're referring to Hawaii, it generated pyroclastic flows, more like a Mount St. Helens type of volcano than what we're seeing in Iceland or in Hawaii. So hopefully that's helpful. Lisa T, and I'll try to hit these questions and give them their due diligence, but I'll also try not to linger on any given question for too long, although I tend to ramble at times. Lisa T, would you do a random road cut episode someday on the drive from Edmonton to Drumheller? I found the descent into the valley to be profound. It's the close walls and seeing the layers. Yeah, if I can ever get up there, that's on my bucket list, is to get. I think the last 3 summers my wife and I have talked about, okay, this is the summer we're going to go to Glacier National Park, go up into Canada, go see the Canadian Rockies, and do this great 10-day loop and come back to Idaho. And every year the calendar gets filled, stuff gets in the way, and it doesn't happen. But please know that that's on my list, and hopefully that'll happen soon. From Martin, is there an online etymologic encyclopedia of geology terms? I find it easier to understand and learn things when I know what the words mean in Greek, Latin, whatever. There is. I probably can't reach it with my headphones on. Maybe I can. Ha! I tried to move with the cord and I disconnected it. So, I'm back on now. There you go. Yeah, Pele in 1902. Right. That's exactly. Can people hear me now? Am I back on? I went to reach for a book and I stretched too far and pulled the cord out of the computer. So, if someone could let me know real quick if I'm on. I'm back. Sweet. Thank you. Okay, so the question was about geology terms and such. So there is the book that I find that's most comprehensive is the Glossary of Geology, the American Geological Institute. You can see how thick that baby is. It is almost 780 pages long. Is there one online? I don't know, but I would guess there is. So let me shrink my face down. That's much better. So that's the best I can do. I have just a paper reference that I use. Is there one that tells you where the names are derived from, Greek, Latin roots? If there is, I'm not familiar with it. From Melanie, I was always taught that the plate boundary goes through Iceland, but now I keep hearing that it goes up past it and has a super volcanic crater up north of Iceland in the ocean. What's up with that? Yeah, I was always taught the same things, Melanie. So let's look at, wonder if it would work. Haha. So this actually shows the plate boundary. Sweet. And let's get rid of all the little chaos here. We don't need all those. So let me clean up the Google Earth real quick here and we can hopefully address. Okay, so here is Iceland, and make sure I got the question right again. A plate boundary goes up through Iceland. The plate boundary goes up past it and has a super volcanic crater up north of Iceland in the ocean. So the plate boundary comes through here. We know it's complicated though, right? It's a series. It's not a straight line like they show here with this green line cutting across there. It's actually a bunch of little northeast, southwest, just like our dike here that they line up. If you connect the dots of all these volcanic systems, then this is the line you get. Then there's actually, it's more complicated than what they show here too. There's actually a system that comes up through here. And then another arm that comes here. Some people have mapped or designated this little central part of Iceland as a microplate. But nonetheless, it comes north of Iceland. It exits out this way, and then you have a series of divergent boundaries, and then the red lines are transform boundaries where they're moving sideways that comes out through here. If there's some sort of super volcano to the north, let me remember your name there, Melanie. I'm not sure exactly where it is, so I don't know exactly where this super volcano is that's under the ocean. Realizing that most subsurface or submarine volcanoes, and there's a lot of them, they're completely passive. They're effusive. They're not typically explosive volcanoes. They just erupt lava quite passively. Get a quick drink. So sorry I couldn't be more helpful there. If you find out something about that, let me know. From Patsy, could increased accelerated plate movement be the cause of recent eruptions among almond plate on plate boundaries? Yeah, so if you get accelerated, it's back to the tectonic volcanic chicken and egg thing that's vexed geologists for decades, and that is, does volcanism drive tectonism or does tectonism drive volcanism? But conceivably, sure, if you had plates moving faster, maybe, and let's just stick with divergent boundaries, plates moving apart, that's probably simpler than subduction zones, which are more complicated. But conceivably, if you have increased plate motion activity, that's probably more increased faulting. If you have increased faulting, you're creating pathways and fractures that could actually allow magma to move through them. So absolutely, that makes sense to me. From Connie's Little Corner, a few Iceland report by folks mention weight of the lava field having an effect on the fissures, etc., and may have a bearing on where the next eruption is. I did that. I swear on one of my updates, we calculated the weight of one of the lava fields, one of the recent lava fields in Iceland. We used the density, we used the area over which it erupted, and we used the average thickness. I can't remember what the numbers were off the top of my head, so you'll have to go back. Just one of the last few updates on Iceland. But sure, to some degree, adding some of that lava to the surface and the weight of that dense rock now is changing the stress conditions locally and may be some small variable in dictating where the next eruptive behavior occurs. That being said, if the magma has a nice conduit and you just put 5 meters of basalt on top of it, if it has enough buoyancy and gas pressure and a good pathway, then that 5 meters of lava is not going to make much of a difference. And you can get future eruptions, recurring eruptions on top of older ones. From Giles Hewitt, are the recent earthquake swarms off the southwest coast linked to the events in Grindavik? There's no connection so far. I was trying not to be too jump in there with like an interpretation, but the idea here is that we've had these quakes off the coast here. But remember, there's another, this is the plate boundary, so it's just another segment of the plate boundary. Is it connected? Well, sure, it's all part of the same plate boundary, but only one given segment moves at one given time to generate earthquakes, and only one given segment typically produces eruptions at any given time. So if we're having an eruption here, it doesn't mean that an eruption is going to happen here, and vice versa. So I hope that makes sense, getting back to your question. So is it linked to the events in Grindavik? I would say right now there's no evidence for that. Could it be linked to it? Possibly. But right now there's no evidence that suggests that. So I would say no for now. From Northern Last, do you think the borehole pressure monitors at Svartsengi really can help indicate an eruption event? I think it's too early to say. I think they noticed elevated temperatures and pressures in one or more of the borehole gauges prior to these eruptive events. So possibly they're worth looking at for sure. But will they be a reliable eruption indicator? I think it's too early to say that for sure. Connie's Little Corner, again, a few Iceland reports by geologists, volcanologists. Oh, we already did that one. Luis Bernier, relative to your next collab, I love these little fun terms. With Nick, would you consider discussing how scientific information gets politicized and how we ordinary people can identify that and deal with it? Yeah, I think we can get into that a little bit. I am largely a apolitical person. I do not enjoy political discussions, and just given our current climate, it's just we've just lost, I think, the ability as a society, largely, maybe I'm preaching to the choir here, to discuss certain topics in a civil, respectable way where we can really listen to each other and hear other perspectives and possibly incorporate those perspectives and that information into our line of thinking. We sort of anyway, I'm getting off on a tangent there. Yeah, I think I can throw that in there. I will be sure to keep this, and I'll see how Nick feels about it. But I think we could probably get into that a little bit. But my gut feeling is I don't want to go too far into that rabbit hole. Rick Floyd, does hot lava weigh more than the surrounding colder rock? Well, when it's hot, it doesn't, because it has buoyancy, it has gases to it. So if we're talking about old basalt lava on the ground and hot, fresh basaltic lava on top, then its weight would be less than that over time. That's why a lot of times when we look at rocks and we're trying to determine their weight, we use something called DRE, dense rock equivalent. Basically, if it was completely cooled, if you took out all the gas bubbles, what would be the mass or the weight of the rock? So from SCH737, Shawn, doesn't have to be on this live stream, but sometime in the future, could you explain the doggone earth? They didn't say doggone, I said that. The earthquake beach balls again. Sure, I'd love to. And maybe what I can do is just do a standalone little video. I'll write it down here on my little idea list. Beach balls. I know some of you love the beach balls and the explanations for those things, focal mechanism solutions, and some of you maybe had nightmares about beach balls. But a good way to confront your fears head on, right? Maybe if we address the beach balls again, we can break some of you through to the other side where things are good and beach balls are acceptable and okay and not something to be feared. Okay, so that's the first batch of questions. Looks like Susan has 2 more for me. So let's try to get through these as best we can. I have no idea how many folks are on here. Yeah, someone said, I just checked the live chat, the USGS does have a nice discussion on beach balls, so you might look to that while you're waiting for me to do something. So, okay, questions. Low stock gamer, is there a danger that particular side of Kilauea will also slip into the sea? Okay, so we're back to Hawaii. Potentially, but I think most of there's very little evidence that these things happen at very frequent intervals. So if you work your way around, not just the Big Island, the other ones, you can see the scarps. I mean, when you're down here near South Point on the south coast, this is a big section where it collapsed into the ocean right here. And you can see how deep it gets on this side. And anywhere where you have these steep cliffs, another fun one over here is Kealakekua Bay, which is, I guess, here. Yeah, so this escarpment right here is another little section where this section of the island collapsed along this escarpment here and collapsed into the ocean. So yeah, I mean the least stable side of Kilauea is its southern flank, because it's not supported, right? It's buttressed up against Mauna Loa on the west and sort of north sides, and so. And the east side is more gradual, I guess. So it could collapse this way, but the south side is shorter distance, right? From Kilauea to the coastline is a shorter distance, and we've got Helena Pali and these cracks that run through here. So I guess I'm waffling on answering the question, but no, let's close that one and open the other one. Sorry. Is there a danger? Yes, but is there a high probability of that happening? I would say low, especially given in anyone's given lifetime. So I'll just leave it at that. From Stephanie CB, at Kilauea, if we were to see an eruption, what would we if we were to see an eruption, would we necessarily expect to see more earthquakes? Could it erupt without having to break any more rock? No, you would definitely see some earthquakes, even if it comes up. We've already established there's a dike there, but to get it all the way to the surface, you've still got to break the rock above it, right? So let's say the dike is at 3 kilometers depth, and you're going to bring it vertically up. You're not going to propagate that dike further down the rift zone. You have to still break the rock above it. It would actually widen out the fractures and move through those. And so, yeah, you'd actually have to break more rocks, so you would see some earthquakes. Yeah, that's it, my answer to that one. Kim Kaufman, are they thinking it will erupt on the power plant this time? Not right now. So she's back to Iceland. There's no data that suggests that even though we're seeing the sill, the magma chamber is underneath the power plant region. In order for it to erupt at the power plant, just like the previous question, I would want to see earthquakes above the sill, below the power plant, that start deeper and get shallower over time. That would be an indicator that the magma is moving up towards the surface near the power plant. From Elaine Jones, Tucson, Arizona, there are some panic reports that say there's magma upwelling under the Blue Lagoon. Any truth to that? Not in the data I'm seeing. There's probably magma under the Blue Lagoon. We just saw it with, I guess we saw it here with this data right here. I mean, let me zoom back in. Oh, that's as far as it zooms in. There's the Blue Lagoon. It's in the red and orange field there. That means that I would interpret that to mean it's sitting on or very close to the magma body that lies at about 5 kilometers depth. But just because what we're seeing is just because there's magma beneath you at depth, that doesn't mean that the magma is coming up beneath you. And that's what we're seeing in Iceland. The magma did come to the surface, but it moved a few kilometers off to the east before it did that. So truth to that, no. And I didn't see any panicked reports about that, but that's the uphill battle. Maybe that's what Nick and I will talk about, is just, all the sites that get millions of views because they've got the sensationalism and the panic, and then all the people trying to just give a more measured response based on the data. And that's kind of what I think he and I try to do. Kathleen, how important is the recent activity southwest along the plate boundary? There have been several quakes over magnitude 4 further south than Shawn discussed. Okay, I think she's referring to like way out here. Like, I think there were some quakes down here. I won't try to pull up a website for those. Part of the plate boundary, and you get quakes down here, but it's a segmented plate boundary. What happens down here, it's not like the magma just injects itself along 100-kilometer length, and we saw that with our eruptions here, right? We saw that where these eruptions took place, they were along these short little linear zones. We didn't see any sort of here we go. So there's December, and here's January. But it wasn't a continuous through-going rupture or vent. That's not the way volcanoes behave. That's not the way volcanoes erupt. So hopefully that dispels that notion a little bit. So I don't think it's that important, and it's offshore, and it's hundreds of kilometers away. It just tells you that the mid-Atlantic ridge south of Iceland is an active plate boundary. So, and what's interesting too is, looking at it now, you see these earthquake swarms, and you're focused on them. But how many of you, and this is not meant to be, just take it for what it's worth, how many of us are watching earthquakes globally over like a decade, for 10 years? Because if you've been watching that long, you've seen earthquakes like this happen in some of these places already, and there was no volcanic eruption or nothing significant that occurred. And so I think it's a lot of recency bias. When we see things over bigger lengths of time, we see that a lot of these events that are happening recur somewhat at some interval. More, not that say that they're cyclical, but you get one here, you get one there, and it averages out to something else. But it's, we're focused on Southwest Iceland, and so now when there's earthquakes and happening in Kruševik area and stuff offshore, we think it's all connected, and that's just sort of the way we kind of wrap our heads around it, when in fact, if you were to look at things in the past, you might see a lot of those same patterns without, the eruptive events. So bit of a ramble there. Oscar, is any aerial thermal mapping being conducted that indicates where the magma is close to the surface? So the thermal imaging that a lot of people want to see happening in Iceland and elsewhere, that doesn't work until the lava is basically at the surface or really, really close to the surface. So right now, if you flew some thermal imaging drones over this part of Iceland, you would see the big lava field here would still be hot because it's still cooling and solidifying. This lava field would still be hot because it's still cooling and solidifying. And that's kind of it. If you go over here by the magma body, it's 5 kilometers down, and there aren't fractures that connect from the surface all the way down to that magma body. So if the heat can't reach the surface through the existing fracture system, and then think of my cross section with all the different layers, different rock types, then you're not going to see those heat signatures at the surface either. And so the thermal mapping only works. It doesn't help you see where the magma is. It helps you see where the lava is, where it's already at the surface. From Kate, could the satellite models with the uplift further west possibly indicate the idea of 2 magma chambers may be more likely? Possibly, because all we're seeing is uplift. We're not seeing exactly, the only evidence we have that suggests where it's at are the earthquakes in terms of the subsurface information. I think that's correct. And so possibly there's 2 sills that are a little bit staggered, one to the east, one to the west, and they're not exactly on the same level. Absolutely possible. We tend to assume, though, the more simpler model until we have evidence to suggest something more kind of chaotic. Amanda Joe, let me check my phone real quick because she has messaged me a few times, and I haven't been watching it, so I apologize. She's saying a lot of questions in the chat about the Nature Eye drone. I didn't mention the news there. So I was hoping to fly the drone in Iceland on Friday because the weather looked pretty good in Iceland. But they aren't able to do that right now. The Johan, who was our great pilot there, lives in North Iceland, and he's tied up there for a little bit of time. They're trying to figure out a way, or maybe they figured it out. They're trying to implement a system that will allow the drone to land without a pilot on the ground. So basically, the idea would be, I sign up for a time, I fly the drone, I launch it from whatever site, we fly around, we take pictures, we have a good time, and then when it's done, when the battery is low, it flies itself back to home. It lands to some docking station, which recharges the battery, and then the flight is over. And then the next person, which could be me or someone else, signs up for a flight. It takes off from the docking station, flies around, and lands. And so they're really hoping to have it automated in that way sometime soon, where they don't have to have a body on the ground that kind of like gets it out of the truck and does that. So I don't know. There's a lot of questions I have on how that would work, but that's what they're kind of working towards right now. So, but the message I got from our good friends at Nature Eye is that I don't have to read it to you, but let me just remember what the essence was of what he said. Johan's up at North Iceland with no transport, so maybe his car is in the shop, or he can't get to the south. I don't know. Maybe someone in Iceland can give him a ride. And they're trying to figure out a drone in a box solution. But he says, I suspect we might miss eruption number 3. And I said, hey, I understand, no worries, and whatever. He says, we're trying to figure out a permanent long-term presence on the Reykjanes Peninsula, recognizing that there's going to be, a very likely long-term eruption cycle that goes on there. So, Liz Cormel, could I ask Shawn, what can we tell from the harmonic tremor plots, please? I'll be honest, I haven't spent a whole lot of time with those. I am not a seismologist. I am not a geophysicist. So I can teach you about beach balls because I'm a structural geologist. I probably don't know enough to to teach you about the harmonic tremor plots. I can tell you that until the magma is like right near this, very close to the surface, and the eruption is either happening or about to happen, very close to eruption, that my understanding is the harmonic tremors aren't that helpful. So they're not going to help you when your magma supply is 5 kilometers down. So sorry I wasn't more helpful there. From Brad and Denise, as a geologist, what are your views on climate change? Oh my gosh, from a geological perspective. Okay, I'll keep it. This is the 2-minute answer. Climate change is real. We can easily look at global temperatures over the last few decades, and we can see an increase in temperatures worldwide. That's fact. Like, no one should dispute that the Earth has gotten warmer over time globally on average. No dispute there. Where this becomes political and messy is when we start talking about, well, how much of it is anthropogenic, how much of it is natural, and that can be an argument that people, just fight to the death on. The second argument that could come up or debate would be, if we agree that some of it is anthropogenic, well, what should we do about it? What should we do anything about it? And I don't know if I want to just get into that right now. From a geological perspective, I can tell you that the Earth has been a lot hotter than it is today. It's been a lot colder than it has been today. But I can also say, as a scientist, I think it's very naive to think that 7+ billion people on the planet with all of our industrial footprint is having absolutely no effect on our climate, given what we know about greenhouse gases and emissions, so on and so forth. So, so I didn't totally show my cards there, but I think you maybe got a sense of where I'm at. So, okay, hopefully we still got some folks here, and let's go to the last batch of questions. And I'm just going to take this third one, Susan, so if you aggregate any more beyond this, then we'll have to save that for the next time. So, and thankfully there's only 3 in here, so maybe I've caught up to all the questions. So let me make that a little bit bigger. The black on white. Very good, Susan. Awesome. And thanks again. Big shout out as we kind of wind down here, team, to Susan for being our moderator. She has asked for absolutely nothing in return. I've offered to compensate her, and she just wants to do it to be a good person and help out. So thanks so much for Susan. She says that's the last of the questions, so that's great. And also thank you, as always, to Amanda Joe, who provides me with so much of the insight into what's happening in Grindavik, and also I think gives me and all of us, I think, a sense of humanity. Like it feels more real what's happening there when, even though I only know her somewhat remotely and through emails, when you know someone that's dealing with that, I feel like it has more gravity to it than if I was just reporting this off of news stations and what we all hear. So anyway, so thanks to both of them, because they're the real stars of the show, and the ones that really make this thing happen. So thanks so much. Okay, from BKY312, would love you to do a field trip down in southern Utah. Well, a field trip. Yeah, I've done videos in southern Utah. My wife and I own property that we hope to eventually build on in southern Utah when we retire, in southwestern Utah near Vail. I would love to do a field trip in southern Utah. Even Moab. Do you mountain bike? Oh my gosh. Moab is great. I've done a couple videos around there. Field trip in southern Utah would be pretty awesome. The wheels are turning. You got the wheels turning. That's a good thing. I'm thinking about where we would go. There's a lot to think about in planning these field trips. It's not as easy as there's cool geology to look at, let's just go. When you're planning these things, you have to think about things like, at least the way I'm doing these field trips so far, like, okay, let's have 20 or 30 people show up. Where are we going to park the cars? How easy is the access? Is it a death march up to the cool, sexy rocks, or can we get to something very relatively easy? Are we in a national park? Because then sometimes you need permits and there's some red tape there. So I am totally down with a southern Utah field trip. It's a big area. Obviously, you can't take 30 people down a technical slot canyon with rappels, which is something I like to do. Yeah, do I mountain bike? Yes, I've mountain biked in Moab. I wouldn't call myself a hardcore mountain biker. I'm more of a climber, but I enjoy mountain biking. I consider myself a recreational mountain biker. I enjoy it, especially in southern Utah. It's super fun. On a nice day, though, when I look in my garage and there's my climbing gear and there's my mountain bike, um, the climbing gear always wins. That's not even a close photo finish or anything. But I do like mountain biking. I enjoy it. So, low stock gamer. I know you're busy, man. You mentioned previously that you'd like to comment on what's happening at Camp Flagrate. Are you still looking to do a video? No, I'm not. I'm not. My bandwidth is pretty full right now. I know there's volcanoes all over this planet, and even if I did this full time, I don't know how I'd keep track of them all. Right now, between teaching classes, family, and I'm teaching 6 classes this semester. Not to I'm not asking for a pity party here, but I've got a lot of classes. I'm taking a group of students to Iceland. I'm taking a group of YouTube viewers to Iceland in May. I just I'm pretty maxed out. So I'm monitoring Camp Flagrate a little bit, but probably don't look to me to get a video on that anytime soon. In a nutshell, I don't think you're likely to see anything happen there anytime soon. These big, large volcanic systems, caldera systems, much like Yellowstone, they have periods of earthquakes, they have periods of uplift, they have periods of deflation and downdropped, and very rarely do they culminate in big explosive eruptions. So I guess I'll kind of leave it at that. And last one here from Ace10, who I've contacted a little bit and got to know. So thank you for all the good stuff you've sent me. I did get your video, Ace10. I just haven't watched it yet. My day was pretty busy, but I will. So thank you for you did some translation. It sounds like an interesting video, and so I will watch it. How large do earthquakes have to be to feel it? Would I feel a magnitude 1 earthquake if it's under my house? Great question. The general rule of thumb is magnitude 3 is a good number for feeling an earthquake. So it depends on a lot of things too. So things that will affect your ability to feel, detect as a human being an earthquake. What you're doing, are you asleep? Are you awake? Are you moving? Are you doing jumping jacks, or are you sitting there in yoga pose, zenned out? So if you're awake, you're more likely to feel it than if you're asleep. If you're stationary, you're more likely to feel the earthquake than if you're moving. Are you driving a car? Not likely to feel it. Are you running on the treadmill? Not likely to feel it. But if you're sitting there watching a Willsey YouTube video or something, maybe you will feel it. But in terms of magnitude, a 3 is a good number. Can you feel like 2.5s, 2.6s? Yeah, maybe people have before. A 1 is too small though. Then another variable to consider is depth. So if the earthquake is very shallow, of course, then as that seismic energy reaches the surface, that's going to produce stronger shaking or more direct shaking than if it's a deeper earthquake. Other variables would be what your house is made out of if you're in a building. So depending on the type of building you're in and the materials it's constructed with, that will affect your ability to quote unquote feel the earthquake. Wood frame versus brick or other materials. And then lastly, the subsurface geology beneath your home or the building you're in. So are you in an area that is underlain by, like if you're in Iceland, it's all basalt and lava flows. Are you in another place that's sediment, like sand and mud? Is it compacted? Is there water, a high water table present? All of those will affect how you might feel an earthquake. But in general, I would say upper 2s, like 2.8, I'd say, to 3 is a good magnitude. And then the depth, and then there's all these other variables I mentioned there. So hopefully that was helpful. On that last question, I'm kind of looking at the live chat. People might have different perceptions. I wouldn't doubt that someone on the live chat or someone else might be like, oh my goodness, there was a 2.1 under my house and I felt it. I'm not disputing that. I'm saying in general, 3 is a good solid number. But if someone tells you I felt a point 0.6 magnitude quake that was, 80 kilometers under my house, maybe they had too much to drink. Maybe there's something else at play there, right? I mean, and then other things about how you feel it are what's your state of mind. Are you alert and awake? Are you groggy and under the influence of something? Those are all different factors that might come into play there. So, pretty sweet. I don't even know how many people we ended up with here because I'm still looking at like the studio version. I guess I could try to open this over here and see. Oh, we got like 1,700 people. That's great, team. Go us. Super proud of you. So hopefully that was helpful to you. I appreciate you all being on here and spending some of your time with me. I appreciate, as I've mentioned, Susan and Amanda for providing their expertise and their help in putting these live streams together. Moving forward, I'll continue to. What's funny is like just real quick little just heart to heart, I guess. I have no idea what I'm doing. Like all the things, well, this isn't totally true. The ideas and videos, there's videos I put together. I'm like, this is the best thing ever. This is going to have 300,000 views. This thing's going to go viral. And sometimes those videos are just like crickets. And then there's other times I do a video that I think is a dumb idea. I think I wouldn't watch this. This is lame. And those are sometimes the ones that get the most views. You just I can't predict it. So all I can say right now is that whatever I've done through trial and error and serendipity and whatever, it seems to be working. Some of you like the random road cuts. If we're just tracking the numbers, which I don't, the random road cuts they're among the lowest viewed videos I put out there. And that's fine. I think the random road cuts is great. I love the idea. I'm going to keep doing random road cuts. So there's a niche for some of you there. The Iceland updates, which I started doing in early November. When I started doing it, I had no idea. I'm like, who really cares? Like at that point, it was like, yeah, there was some stuff in the news, but it wasn't November 10th yet. I think my first one was like November 3rd. There was signs things were happening. Like the Iceland was on the move. There was some shaking going on. And I did it mainly just to kind of like, for me to process the data and then just, I don't know, like vent or share that data so that I understood it better. That's sort of what I did. But then those went crazy, right? And obviously, it helped from a view standpoint to have, I mean, it wasn't what I wanted, of course, but Grunewald gets evacuated. There's the earthquake swarms, there's the destruction, then there's 2 eruptions. I mean, obviously those are big deals. So, in hindsight, yeah, those would be big videos, but it's hard for me to predict like what people want. And so I guess what I'm saying is that I'm doing a lot of different things, but I'm enjoying all of them. They seem to resonate with some of you. They seem to be of value to you. I'm learning, and hopefully you're learning. And so I'm going to kind of keep doing these. I've got some different outdoor field venues I'll get to. I've got some other videos I've done that I was just going to pull up. I have a little spreadsheet here called YouTube Video Backlog. I've got a Joshua Tree National Park video I need to put together, so look for that. Mecca Hills, which is down in Southern California. The Newberry Detachment Fault in Nevada. Mount Rushmore still in South Dakota. There's a double plunging anticline in Wyoming. So I've got I'm down to like, I think maybe 10 or so videos that are just sitting on the hopper that I just need to kind of put out and launch. So look for some of those. Look for more random road cuts, maybe a couple a month, something like that. And then, of course, look for these Iceland and Kilauea updates. But now we're kind of branching out, right? Like I did the little thing with Nick, and he's going to come on ours. And so I'm open to those kind of ideas. If that goes well, I think it'd be fun to bring in, I don't know a lot of geologists to some degree because I don't know why my Teams thing keeps opening. Because I'm a one-person department here at the College of Southern Idaho. But I do know a few geologists and maybe bringing them on to have them talk about what they do and their expertise. Yeah, and just filming my little adventures that involve geology, whether that's river trips or climbing trips. I don't know. I'm kind of rambling here, but I think the idea is I'm going to keep doing what I do and what feels fun and informative and gets me excited. And I hope and trust that some of that will stick and land with all you good folks there. So hopefully that makes sense. So I think that's about it. I'll go through this later and read through the live chat. There's always good comments there. As always, you can email me, but realize my email inbox is bulging, and I try to get through those as best I can. So know that I will get back to you at some point if you send me an email that necessitates a response back to you. So I'll try to do that. But for now, let's just keep our eyes on Iceland. It looks like Kilauea is taking a break. Good chance I might be jumping on with you, within a few hours, maybe tomorrow, maybe this weekend. But within the next few weeks, if something goes down, I'll try to provide the best information I can. May not be able to get the drone up, which is kind of a bummer, but if that changes, I'll let you know, and I'll try to have that ready to go. But I still think we can use the webcams, we can use the data, and we can still see what's happening and discuss it as best we can. So for now, I think I'll go ahead and sign off. Thanks again for joining me. Thanks for being a loyal viewer, for your support, your encouragement. All you do, it means a lot to me. It's great for me to be able to share what I love with so many people. Helps my wife out because then she doesn't have to hear me talk about rocks and volcanoes and stuff because she's not as much into that, but we have other interests we share. So she's great. Okay, so I'll go ahead and sign off and be well, take care, and we'll see you next time.